Hello, welcome to another session of data structure. In this session, we will be looking at hash table. All right, hash table is a very interesting data structure. I don't know if you have ever stopped to think about how the password to your accounts have been stored. By this, you should realize that when you create a password on a site, for example, on Facebook or Gmail, that's on Google, or whichever site you would have created it on, most of these sites would have applied some amount of hash function in securing your password. The big idea is that if you enter Jamaica as your password, the actual word Jamaica is not stored. But what happened is that they would have hashed that word to generate a key, and then that key would actually be stored in terms of the hash code. That's what would be stored in the database, or whatever place they store your data. All right, so if somebody should have hacked in that, they would not be seeing your actual password, but actually the hash code. All right. Now, by hash table, a hash table is a special data structure, as we mentioned earlier on, that stores and associated data. All right, that means it stores a key and a mapping value. So just like with the password and the hash code, so it would store a hash code that would then match to the actual password. All right, and so when you try to log into the system, then it would try to regenerate the hash code, and if it matches what is stored, then you would be actually allowed in. All right, we will not get into that amount of cryptography for this session, but we'll just look at hash table from a very simple point of view. All right. So what you need to take from this is that a hash table maps keys to values. All right. So the hash table maps keys to values. I'm going to look at how this mapping is done by using some hash functions. All right. So here on the right of your screen, we have what is known as a hash table. All right. And a hash table has a size, all right, that ranges from 0 to whatever the size is. That it's simple 0 to whatever the size is because the first index starts at 0. So you can look at it just like how you would look at an array. So if the hash table is size 7, it means that it has index from 0 to 6. And we know that from 0 to 6 is 7, all right? The beauty about the hash table, guys, is that it has constant time access. So it means that accessing data is very fast. So once you know the key, you will be able to jump straight to wherever the data is stored. There's no need to read any previous data before you actually get to the one that you're trying to find. All right, so the access time is actually constant time. A hash table can be viewed, as I mentioned earlier, just like an array. Normally, the size of the hash table is expressed using a prime number. So we normally use a prime number for the size of the hash table. Ideally, doesn't mean that it will always be that size. All right. So, for example, an ideal size of the hash table could be 7 or 5 and so forth. All right. If you use other numbers, the likelihood of collision is eminent, but nevertheless, we still use some other numbers. But if collisions do occur, we know how to deal with those. So we'll look at those. And by collision, I mean you would have generated a key that points where more than one key points to the same location. And in a situation like that, we have what is called a collision. All right, so let's look some more on this. So here's an example. So we have a hash table here of size 7. So it ranges from 0 to 6. All right, so that's 7. All right, so here we have some numbers to be inserted into the hash table. All right, so we have the values, and what we're going to do now is to generate the keys by using the hash function that is listed on the screen. So the hash function that we are working with here is h of k equal to k mod 7. And by this time, you should know that mod is the remainder of, gives the remainder of a number when it's divided by another number. All right, so in this case, K represents the number. So if K is divided by 7, whatever the remainder is, that is going to tell you which index the value is to be stored. All right, so let's look at how we would go about this. So for 7, the first number to be inserted is 7. So what we would say is 7 mod 7. All right, so the hash of 7 is 7 mod 7. So whichever number we get, that is going to determine the index that we should actually store the value 7 at. All right, so to get the key for this, that is where 7 should be stored, we're going to say 7 into 7 goes 1, and the leaves a remainder of 0. And so h of 7 is 0. All right, so 7 divided by 7 gives a remainder of 0. Therefore, mean that 7 will be stored at index 0. All right, as you can see here. The next number that we have using this function h of k equal to k mod 7 is 18. So we are going to be finding 18 mod 7. And you can guess and tell what is 18 mod 7. All right, so all we're going to say is 7 into 18. That goes 2 times, and 2 sevens, 14. 18 minus 14, that's 4. Therefore means that 18 should go to index 4. That's right here. All right. Now let's look at 41. All right. Where should we put 41? So all we're going to see again is 7 into 41. And if you check correctly, you realize that 7 can go into 41 5 times. All right. So what is the remainder? 5, 7 is 35, and 35 minus 41, that is going to be 6. So therefore means that 41 will go to index 6. All right. Now the next number that we have is 94. Again, we apply the same procedure. So we are going to say that we're going to say 94 mod 7. So all you need to find out is how many times can 7 go into 94. All right, so you just divide 94 by 7 and find the check how much time. That's 13 times. And what is the remainder when it goes in there 13 times? The remainder is 3. All right, so therefore mean that 94 will go to index 3. And that is it. That is how you would go about inserting data into this hash table using the hash function h of k equal to k mod 7. All right, so that is a very basic in terms of how to assign values to your hash table. All right, now let's look at another example. So here we have another example. We have table size 6. All right, this is table size 6, and what we are going to be doing for this one is we are going to be assigning these values 7, 18, 41, 34. All right, so let's do this one together. All right, so what we're gonna do, first number to be assigned is 7. So we're gonna say 7 mod 6. What is 7 mod 6? All right, so we say that 7 divided by 6, that goes 1, and the remainder is 1, so 7 mod 6 is 1. That therefore means that 7 is gonna go into 1. The next number is 18. So we're gonna say 18 mod 18 mod 6, and 18 mod 6 is, so 6 into 18 goes 3 times, and the remainder is 0. Therefore mean that 18 is going to come here. All right, and our next number is 41. So let's say 41 mod 6. How many times can 41 go into, how many times can 6 go into 41? All right. All right, so if you get 6, you're correct. So 6 is 36, and therefore mean that our remainder would be 5. Therefore mean that 41 would go into index 5. And the last number we have is 34. That's going to be 34 mod 6. All right, so 34 mod 6, how many times can 6 go into 34? All right, so 6 can go into 34 5 times. Remember, 5, 6 is 30, so the remainder is going to be 4. All right, so remember, 6 into 34, that's going to be 5, and 5, 6 is 30, and 34 minus 30, that's 4. Therefore means that 34 will go to index 4. All right, so 34 will come right here. All right, so we have been having some good cases so far. All right, but there are some other situations that we are going to be looking at, some which may end up with some collisions and so on and so forth. All right, so please make a note of this and let's continue. I'm going to erase this as we move on. All right. Now, when you are choosing a hash function, we have to make sure, you have to make sure that it's a very simple function, as you would have seen earlier on. Ensure it's a function that helps to avoid collisions. We do not want to have more than one value having a key to the same location, all right? So we need to try to have the keys distributed a bit evenly. That is why we are encouraged to even use a hash table of prime number in terms of the size, all right? All right, now collisions will happen in your hash table. All right, so as much as we try to avoid collisions, we will have collisions. That means it's possible to have more than one value being assigned to the same key. All right, so there are two main methods that we have to resolve the collision. We have the separate chaining. We also have the open address hashing, different open address hashing techniques like linear probing, quadratic probing, double hashing. All right, so we'll be exploring at least 2 of these in this video. All right, so the first one we are going to be looking at is the chaining, or the separate chaining. All right, so with chaining, what happens is that whenever there is a collision, so if 2 values are mapped to 1, what we do is we would create something like a link between them, just like how you would have established a linked list. So we establish a link to the different values that are inside here. So let's look at what we were talking about. So we don't move down and try to find an empty slot, but we create a link or like a chain, right? So all the keys that map to the same hash value are kept in a list, or if you want to call it a bucket, and so it will form like a chain to the location. All right, so let's look at an example. All right, so we have these values to be inserted. Let's say we are using h of k, where we have k mod 10. All right, so we have these values to be inserted. using h of k, and we're saying the hash function is h of k equal k mod 10. All right, so let's work out these. All right, so let me just type it, might be easier. So if we have h of 10, the first number to be inserted, h of 10. All right, so we are saying h of 10 would then be equal to 10 mod 10. So then you need to ask yourself, how many times 10 can go into 10? All right, so 10 can go into 10 just one time, and the remainder is going to be 0. Therefore, mean that 10 will go to the first index, which is here. All right, so 10 will come here. You're following that? All right, so the next value that we have is going to be 22. Similarly, we're going to say 22 mod 10. 22 mod 10 is going to be equal to what? So we say 10 into 22 goes 2 times, 2 times 20, and the remainder is going to be 2. Therefore, it means that 22 is going to go to here. Sorry. All right. The next number that we have is 107. All right. So all I'm going to say is 107 mod 10. So what is the remainder when you divide 107 by 10? So let's check it. So 10 into 107 is going to be 10, and the remainder is going to be 7. Therefore, mean that 107 is going to come here, index 7. All right, the next number is 12. All right, so 12. So you're going to have 12 mod 10. Again, 10 into 12 goes 1, and the remainder is 2. All right, so the remainder is 2. So since the remainder is 2, it therefore means that 12 is supposed to come at this location. But if you notice, there's something there already. So since something is already there, what we're going to have to do is to chain. All right, so because it's a collision, because something is already stored there. So you're just going to put a little line, and we're going to show that it is connected to 12. So we're going to put 12 there, and we're going to use a line to show the link. All right, so let me just get a line to show. All right. Good. So we're going to use this line to show the link. All right. So it therefore means this is indicating that there's a chaining going on here. All right. So the next number that we have is 42. And if we work out 42, so it's going to be 42 mod 10. And that 2 is going to be equal to 2, because 10 into 42, 4, remainder is 2. Therefore, mean that 42 should also go into 2. So we should have 42 here. But because there's a collision, we're going to show that it's actually chained. All right, so 2 values here are connected. So that is what the chain would look like. All right, so this is what our hash table would look like. All right, so the 12 and the 42, since they are mapped to the same location, they are actually chained. And this is how we resolve the collision using the chaining method. All right. Okay, good. So we're going to look at some other techniques. All right, so we're going to look at like the linear probing, which is also used to resolve the collision. All right. So let's continue. All right, so with the linear probing, the collagen is resolved a little different. All right, so let me just erase these. All right. So let's use the same function for this one. Now, first of all, the linear probing. So whenever we are hashing using and resolving the collagen using the linear probing, what we're simply saying is that if we hash a value to 0, right, the first value would go into 0. If we hash another value and the index for it is 0, what we're going to do is just move down the table until we find an empty slot, and we're going to put the value there, right? So you're just going to keep moving down until we find an empty slot. So pretty much that's what this is saying. So if we do h of k, if it's empty, we can put the value there. If it's not, we do h of k plus 1. All right. If h of k plus 1 has something there, we're going to move on to h of k plus 2 and so forth. So we're going to just keep moving down until we actually find a space. All right. And if we come down to the bottom, we just move. It's pretty much going to take us back to the top. All right. So let's look at how we would insert the data for this one. All right. So the hash function that we are using is h of k equal to k mod 10. All right. First number, 38. So all we're going to say is 38 mod 10. 38 mod 10 is going to give you 8. So therefore mean that 38 should come here. All right. The next one we have is 19. So we have 19 mod 10. 19 mod 10 is going to give us 9. So that's 10 into 19 goes one time, remainder 9. So therefore mean that 19 is going to go into 9, next 9. The next one that we have is 8. So all we're going to say is 8 mod 10, and that's going to be equal to 8 because 10 can't go into 8, so the remainder is going to be 8, all right? So since the remainder is 8, what we would do is we would attempt to put 8 here, but if you notice, we have something stored at 8, all right? So we're gonna have to move to h of k plus 1, so we're gonna move to 9, all right? So you notice that there's something actually stored at 9, all right? So the next thing that we'll have to do is to go back up to the top. All right, so since something is stored at 9, we have to go back up to the top. And then we will store the value 8 here. All right. That's how we do the linear probing. All right, so next value we have is 109. All right, so we have 109 mod 10. Again, this is going to lead to a collagen. So 109 mod 10 is going to be equal to 9. So therefore means that 109 should go into index 9, but this is the end. So what we're going to do is go back up to the top. All right. So 0 is occupied. So we're going to come down, and the first space that we found here is 1. So we're going to put the value here. So 109 would come here. All right. So that's the idea of the linear probing. And next we have 10 here. So again, this is going to be another collagen. So we have 10 mod 10. That's going to give us 0. So we would attempt to put it here, but we realize that index 0 is occupied. So going to come down, and index 1 is occupied. But when you come down to 2, you realize that 2 is not occupied. And so 10 would come here, right? So that is how we go about doing the linear probing, and that is how we go about inserting data into our hash table. All right, so thank you very much for watching this video, and I hope you found it useful. All right, so there are other techniques that we can use that I may create other videos to highlight. So thanks for watching, and be blessed. Stay tuned for the next video.